Hi there. All right, in this example, we have a situation where we have a leading coefficient that is 3. Now, we don't want to do that. When completing the square, we need to have a leading coefficient of 1. So we can do still a little bit of math magic or math manipulation and make it like that. So what the rule is like, well, common factor out the first two terms. So, well, common factor, but only the 3. So we're going to take out the leading coefficient. So whatever it is, if it's just negative x, factor out that negative x. If it's a 2, take out the 2, and so on. But you're going to do it just for the first two terms. So we're just going to do it for the 3x squared and the minus 12x. And you're going to see why in just a moment. All right, so let's do that. So if we divide our 3 out through 3, and then we have left x squared minus 4x. Nice. This is now the expression we're going to work with. We're going to now common factor this baby. So we can do that. That's great. And I'm going to use the tiles as my example again to show you what the situation looks like and how and why we add certain tiles. So let's do it. So we have an x squared. I'm just focusing, by the way, in just inside the bracket because this is all we're completing the square. This is our focus part right here. Oops. So this is it. X squared minus 4x. So we're going to do the representation for that. So I have x squared. And now I need to grab 4x tiles and they're negative 4x tiles. So I'm going to grab, so there's 1, 2, 3, and 4. And don't forget that when you're dealing with these x squared tiles or negative x tiles, how I'm going to wrap it around the square is I'm always going to separate into two equal parts. So it's going to drag that down to make it horizontal. So my two equal parts is where I have two of the negative x squares tiles, negative x tiles, sorry. I have them doubled here and doubled here. Well, that's it. That's all we have for in here. But remember, to complete this square, we need to fill in some values here. And this is where the 1 tiles fit in. So I'm just going to grab as many 1 tiles as I can to fill this space. And as you can see, I'm going to need 4 tiles, but I can't just add 4 positive tiles. I need to also balance that out with 4 negative tiles. So in the other examples we've done so far, we've always had it where there was some 1 tiles already there. But this is what throws us off all of a sudden is because technically we have a plus 0 here. So we don't have anything, any little 1 tile. So we don't have to think about how much more do we need to add. We're just blanket adding 4 1 tiles that just didn't exist at all. We didn't have any 1 tiles. And then to balance it, negative 4 1 tiles. So let's represent this now up here in our equation. So, oops, let me just change that pen color. So we have back to black. We have, as an equal sign there, 3. And inside the brackets where we did the work, we had x squared minus 4x plus 4 minus 4 and then the plus 17 out here. So that's how we get this plus 4 minus 4. Now, if you don't want to rely on algebra tiles to come to that rationale, the pattern here is always to take this value in front of x. So your b value, you take half of it. So you take 4 divided by 2, which is 2. And then you take that value, whatever you found it to be, and then you square it. That's how we always get to these same 1 tiles. Okay, so that's the pattern, and that's just because a perfect square trinomial, that's how it comes about. So I know sometimes it's hard to get our head around it, but if you can get your head around the completing the square like this, then maybe you can just trust me when it means when we're going to take this value in front of b, take half, and then square it, and that's going to be your value that you're going to add and subtract. Okay, let's finish this off. We don't want we only need 3 terms in here in order to do the perfect square trinomial. This is already set up perfectly. So I got to get rid of the negative 4. So it's getting kicked out of this bracket because like, no, 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 we only need 3 terms. We need this out. But because of the 3, we have to multiply 3 times negative 4 in order to get rid of it out of the bracket. So you can distribute it. And that gives us negative 12 plus the 17 that's already out here. So let's simplify this now. X squared minus 4x plus 4. To do this, we just take half of this or the square root of 4. Either way, you get the same value. So it's x minus 2 squared, and the minus sign matches here. And then we just simplify this and we have plus 5. So we found the vertex to be 2, positive 5. All right, so I'm hoping with the visuals of the algebra tiles, you can make that connection as to why we took out the leading coefficient of 3, because in order to complete the square, I do need to have a leading coefficient of 1 in my expression. Okay, good luck.